In this video, we'll be looking at section 4.4, variation. Direct variation. A direct variation is also called a proportional relationship. It can be represented with the form of the equation y equals k times x, where this k we will see continually throughout this lesson. K is some non-zero constant. And x and y are the input variables. This proportional relationship is one that you have a lot of experience with. Let's look at an example. It's one of the first sort of relationships that you studied in mathematics. Let's say we wanted to look at the relationship between two variables, x and y. Let's let x equal the hours you worked, and let's let y equal your pay. Okay. Well, let's say you're making $8 an hour. Clearly, if you work 0 hours, you won't make any money. If you work 1, you would make $8. Pay in dollars. If you worked 2 hours, you would make $16. 3, you would make $24, and you get the idea from there. All right. This k is what gets you from x to y. And in this case, to find k, you would simply divide y by x. Y divided by x. K is going to equal y divided x. So we can't divide 0 by 0, that's undefined. But the rest of these you'll see it's 8. 8 divided by 1 is 8. 16 divided by 2 is 8. 24 divided by 3 is 8. So this relationship here would be modeled by the equation y equals 8 times x. We would simply substitute any of these values in for x, multiply it by 8, and we'd get to y, our pay. Given some hours, you could multiply by 8 and get to what the pay is. This 8 is my k. It's often called the constant of proportionality in this context. All right. Inverse variation. An inverse variation is modeled by the equation y equals k divided by x. Here you can see that our input variable x is in the denominator. Well, that's going to do some special things to our situation. Let's look at an example of an inverse variation. Again, k is some constant. K is a non-zero constant. All right, example. Let's say that you're going to paint a house. All right. Let's let x be the number of people involved in the painting. People. All right, and y be the time that it takes to complete this task. Let's say that if you do this by yourself, this house painting by yourself, if there's one person, it's going to take 12 hours. Well, consider if you have 2 people, let's say assuming that we work the same pace, how long would it take? Well, if we doubled our people, it should half the time, shouldn't it? Okay. Well, if you had 4 people, if you doubled those 2, it should half this time. Half of 6 is 3. Again, we're assuming that everybody's working at the same rate. If you tripled this 2, that'd be 6. Well, it would 1/3 this time too. And you can see this pairing here. If 2 goes to 6, then 6 goes to 2. Well, imagine if you had 12 people, then it would take 1 hour, wouldn't it? If one person took 12, then 12 would take 1. Here we see a different relationship. Here with this k positive as x increased, y increased. But here, as our x increased, the y decreased, because we're dividing by that x. The more we divide by, the smaller the quotient. All right? So the more people we had doing the job, the less it took. That makes perfect sense. Here, to find this k, we're simply going to multiply x times y. 1 times 12, that's 12. 2 times 6, 12. 4 times 3, 12. 6 times 2, 12. 12 times 1, you guessed it. So in this case, the product of all of these x's and y's will be one constant. All right. Sometimes we'll have what's called a joint variation. And a joint variation is just more than one of these direct variations. When one variable varies directly with two or more. For us, it'll be strictly two other variables. All right. And we might have a situation like this. Instead of it just being y is equal to kx, like our previous one, now we're going to have another variable like z. Okay. Instead of one input variable x, now we have two input variables x and z. This k is still a constant. K is a non-zero constant. Here we would say y varies jointly with x and z. I would read this as y varies jointly with x and z. Okay. In this one here, we say y varies inversely with x. And in this one, we say that y varies directly with x. All right. One last, I'm just going to call this other variations. We can combine those. We can combine the above variations. For example, it might say y varies directly. Example. All right. We might say y is equal to k, my constant, x over z. Okay. Here we would read y varies directly with x. It's in the numerator, but inversely with z. Y varies directly with x and inversely with z. So we can combine this direct and inverse at the same time. When it's in the denominator, it's an inverse. When it's in the numerator, it is direct. All right, I'm going to skip directly into some example problems from our XYZ. Okay. Call this one number 1. This is much like number 1 on your XYZ. It says, first I'm going to get to the question sentence, make that a habit. It says find y, okay? We're looking for y, find y when x is 3. It says y varies directly with x. If y equal 10 when x equal negative 5, find y when x is 3. We'll begin with our form, our direct variation form. Direct variation is our form y equals kx. Start there, okay? Step 1, find that value k. All right, so I will begin with, instead of writing y equals kx, I'm going to use this value they give us. It says y is 10 when x is negative 5. So instead of y equals k times x, I am substituting in place of x negative 5 in place of y 10. So 10 equals k times negative 5. Alright, all I did was take my form y equals kx. I substituted the y that I knew in the corresponding x. This is going to allow me to find k. If k is negative 5 times 10, dividing both sides by negative 5, then I get that k is 10 divided by negative 5 is negative 2. That's my value k. That's my constant of proportionality. Okay. Step 2. Use k to solve problem. All right. So now I know k is negative 2. I'm coming back to my form. Y equals kx. In place of negative 2, in place of k, I'm substituting my negative 2. So I have y equals negative 2x. I have an equation here. My problem says it says find y when x is 3. So my question is this. If x is 3, what in the world is y? So I just need to take 3 and substitute it in there. Y equals negative 2 times 3. And negative 2 times 3 is a negative 6. When x is 3, y is negative 6. All right. Number 2. It says y varies inversely with the square of x. If y equals negative 2 and x equals negative 3, find y when x is negative 8. All right. So we begin with our inverse variation form. Our inverse variation states that y is equal to some k divided by x. We're going to find this k. But this time it says inversely with the square of x. Since it's the square of x, I'm going to square this. Okay. Y varies inversely with the square of x. Now I can find my k. It says if x is negative 2, when x is negative 3, y is negative 2. So substituting, y is negative 2 equals, k was what I'm trying to find, and x is negative 3. All right. Negative 3 squared is 9, so what I have is negative 2 is equal to k over 9. Something divided by 9 is negative 2. Remember, if you have a fraction, simply multiply by that denominator and that gets rid of it. Multiplying by 9 on both sides. Thus, k is negative 18. This is my value for k. Now it goes back into my equation. We have y is equal to, instead of k, substituting negative 18, x squared. Okay, so this was step 1. Step 1, find K. And that depends on my form. I need to find the correct form. All right. After we find K, step 2, use K to solve the problem. So we have taken this K is equal to -18 and we've substituted it in there. Now we're ready to solve the problem. It says find Y when X is -8. We want to find Y. We don't know where Y is, but we do know that X is -8. So I'm going to take -8 and substitute it in place of X. Y equals -18 over -8 quantity squared. So this is -18 over 64. And you could reduce this to whatever it might be. Looks like -9 over 32. You could enter that in just like you see it. That's what our Y is. Y is -9 over 32. All right. One last example. Z varies jointly with Y and the square of X. Remember, jointly is direct variation. More than one. 2 or more. Okay. Alright, so if it says Z varies jointly with Y and X, perhaps we have a picture in our notes of this. Here I say Y varies jointly with X and Z, so Y is equal to, here we have X and Z, and of course we have our constant K in there. Alright. Z varies jointly with Y and the square of X, so Z is going to equal some constant K, always a K, times Y and the square of X. Z is joint variation, that's a direct variation, with Y and the square of X, and we have this K there. Alright, so step 1, find K. It says Z is -64. K I'm going to leave as a constant. Y is 8. And X is 2. Okay. Now I can find my K. 2 squared is 4. 4 times 8 is 32. 32 times K is -64. So dividing by 32 on both sides, K is -2. Now, that was our step 1. Step 1, find K. Step 2, use K. Use K. We're talking about substitute into that original. Alright, so our function was Z equals K times Y, K times Y times X squared. So Z equals, our K is -2. -2 goes in there. I'm going to rearrange this as X squared Y just because that's typically we see it in alphabetical order. Alright, I knew they were multiplied together because it said jointly, and jointly is a direct variation. Okay, so now let us substitute what we know. It says find X when Z is 192 and Y is -6. So Z is 192. 192 in for Z. -2 remains. Find X. X I don't know. I'm going to leave it as X squared. Y though is -6. All right. Well, multiplication is commutative, so order doesn't matter. I can multiply negative 2 times negative 6. That gives me 12x squared. There's 192. Solving for x, I'll divide both sides by 12. So x squared equals 16. X squared is 16. So now I take the square root of both sides, and I get that x is both positive and negative 4. Those are my answers. And when you do it on XYZ, you'll note that it says x is equal to box, comma, box. So you will write those two values, positive 4 and negative 4. All right. I would suggest as you're taking these notes to try working one example of each one from XYZ as you're going through it. So work the XYZ as you are viewing these notes. And that concludes this video.